189 was at 3.
What number? Okay.
29.
Oh. You grabbed your quiz?
Yes. Dude, you did better than me.
Your face. You talking? What you best?
Trying to figure out how I fixed it. Number 3D. Wait, which quiz you got? A or B? Yeah, so 3D. And Mr. Harris. Oh no.
Yeah, grab that.
Hey, I did not get that one right.
Did you see what you missed?
I can't tell. Like, how'd you get rid of that X?
So when you have over 2x minus 1 squared, it would be, did you show denominator times derivative for numerator?
No, I didn't see the other thing.
Numerator times derivative.
Yeah, it's probably right.
Because they subtract out. The x is, let me show you my key.
Yeah.
See, look at this. 6x minus 3 minus 6x. They cancel. See when you do that?
Yeah.
I think I just, like, because whenever what I did is I did the quotient, or what's it called? The chain rule instead.
Oh.
So I just factored it on.
If you wrote it like that, you have to do product rules. If you wrote it 2x minus 1 to the negative 1, you could do chain, but you have to do product.
Yeah.
So that would make it tricky. You did that, right? What did you put up there?
Oh. I saw your handwriting was helping.
That's why I just took off one. But you saw that shit, but you didn't distribute your that. Just a small.
I'm not really sure how I
Oops, sorry. I think I just.
Oh,
So if we do this one, this was page 189. You said product rule and chain rule within it. So we will say first times derivative of second. What's that going to be? Derivative of outer times derivative of inner. All right? Plus,
3 minus 4.
reverse it. Derivative of first will be 4x to the first times original second, 3 minus 4x to the fourth. The book, instead of writing the 4 here, and then I wrote it as, I think, negative 32 x squared 3 minus 4x to the third.
No, the book had your answer there.
Oh, is that what they had?
That's what they had.
You could simplify it if you wanted to. And I thought they might even have tried to factor it. You know, this would look a lot better than that first answer. So, but that's all you have to do.
So we don't need to simplify it down all the way then?
Not on my test. Just if you're doing your homework and you need to check your answers, try to make it at least match. And that could be a headache sometimes. But on my test, if you did this, I would count it right. Okay. But look how nice on your quiz, though, that quotient rule, the numerator did, cancel down to -3, which was so nice. And I would like that if you could do it easily. But see, that's not going to be easy to simplify. But I think a lot of times they would try to factor out the GCF from this and make it even simpler. And that gets to be just time
12
consuming.
minutes.
So, any others? 49. Ouch.
That's what I said.
1, h of x is 3x squared plus 1 to the third power over x squared minus 1 to the fourth. You all see we're going to have to use quotient rule and chain within that.
So you would do chain first.
Just think of it as quotient rule. Remember our quotient rule says denominator times derivative of numerator. Well, now that I take derivative of this, it's chain. 3 times 3x squared plus 1 squared times the derivative of inside is 6x, isn't it? Look at that again. Denominator times derivative of numerator minus numerator times derivative of denominator. Well, that's going to be 4 times the x squared minus 1 to the third. And what's the derivative of the inner? 2x over x squared minus 1 to the fourth squared, which would be to the eighth. Now, you tell me, how much of that do you want simplified, or do you want to leave it like that? But the book didn't leave it like that, did they? I would say the book would probably take the 3 times 6x and put 18x out front, and then they might put the 8x here out front. Then they might even factor it. But I'm fine if you just sort of did that. If you put 3 times 6x, 18x here, and you put 4 times 2x, 8x there, I'm great. I'm happy. And I know that you knew the quotient rule and that the chain was within that. So. But you see what I'm saying? When you see this, I want you to think quotient rule. But as part of the quotient rule, when they say take the derivative of the numerator, you have to use the chain rule, don't you? Denominator times derivative of numerator minus numerator times derivative of denominator over denominator squared. Okay. Don't get too caught up on the simplifying. As long as you understand what I just did there, and you know both the quotient and the chain, I'm good. So, okay? Any other questions before we move on? Did you feel okay with 3 through 17 on the marginal cost, revenue, and profit? Were those okay? Hopefully those were easy like the ones we did in class.
I didn't make it to follow it.
But that's a short number of problems, so maybe when you look at it, when you have time, it'll go well.
I'm just wondering, was the book answer for 13A correct? I'm getting something different, but all my other answers in that question are correct.
13A was... So if you wrote it to the 1/3 power, right? Is that...
On the page 206.
Oh, 206.
I think it's for the profit function that I'm getting.
The revenue function and the profit function? Did you say the revenue function was P times X, which was 600 minus 0.05X times X?
I got that one was fine.
That
It's the profit part
The profit.
that I'm not getting what they're getting.
I would say that if you said your answer from revenue minus their cost, you might have made an error when you distributed your negative. If you could bring that up afterwards, let me look at your answer and I could see if you wrote out the work. Let me look at it. And they could have made an error. There's an error in one of the ones that we're going to work today, that I'm going to work for you, that I found last semester or last year sometime that they had a wrong answer for. So it's possible. But just show me your work. But it's just it's a huge mess, isn't it? When you say revenue minus all those big decimals, you
Well,
could have.
I took my negative distribution, but it wasn't that.
I'll let me look at it afterwards. Okay. We are skipping 3.5 until the Next unit, we're going to 3.6 today. I did look at the syllabus and I thought we were clipping along really well, and it seems like we're already behind. But I think things start to, the sections that I've listed sort of slow down a little bit after this next few weeks, so maybe we'll catch up, because I hate to rush you at the end. But I am sort of, yeah, we're short a week because of the Mondays, right? Yeah. So, okay. Page 225.
We just won't do the last section.
225. Look at this.
How about that?
What if I asked you this? And don't write this down, just sort of look at it. What if I said, find the derivative? Could you do it? All we've done so far is if it's solved for y. If it's a function of y, that's not a function, is it? That's a hyperbola. You've studied hyperbolas before? That's not a function. It doesn't pass the vertical line test. Its graph would look something like this, not a function. But we still might have an equation like that where they say find the derivative, and I need to show you how to do that. And that's what we're going to look at today, and I hope you're going to like it because it's not too difficult. It's called implicit differentiation. Implicit differentiation. Method of differentiating an equation to find dy dx, the derivative, when y is not an explicit function of x. Okay? Can I find the derivative if it's not even a function, if it's not even solved for y? And the answer is yes. Okay? Here's what we'll do. This is the process. Differentiate each term as usual, but attach dy dx to any term involving a derivative of the y variable. Okay? Then solve for your dy dx and substitute values into the result if needed. Okay? So I bet an example would go a long way right here. Okay? I think the best one that we could look at to show you what I'm talking about is number 2 on page 225. They give you 3x plus 4y equals 6. And that's not solved for y, is it? Well, if you follow those instructions that I just had up there, I'm going to take the derivative term by term, but any place I take a derivative of a y, I'll tack on dy dx by the chain rule. Look at this. You know what this derivative is. What's the derivative of 3x? 3. What's the derivative of 4y? It's 4, right? Same thing as the 3x, it was 3. The derivative of 4y is 4, but since I took a y derivative, the derivative of that y, I'll tack on dy dx. Okay? 4 dy dx. Because the derivative of 4y is 4, but the derivative of that y expression, whatever it is that I don't have, is dy dx. Okay? Equals what? Derivative of 6 is 0. Solve for dy dx. What is my derivative? How do you like that? Okay. To show you that that worked, what if I started this problem by solving for y? What if I subtracted 3x from both sides? What would it be? You agree with that? If I divide by 4, what is y equal to? What if I said find the derivative of y prime? What is it? Wow. It's the same answer, isn't it?
Why would you do that?
Isn't that cool? Because if you look toward number 30,
Okay.
What if I said solve for y number 30? Could you do it? You'd be hard pressed, wouldn't you? Would you be taking a 10th root and then subtracting, taking another square root? And then you're just crazy, aren't you? So, okay? But that was, I thought, a good simple example to show you the process and to show you, hey, it works. That's the derivative, isn't it? Okay? Now, when can we really use that? Number 10. What if I say find dy dx, derivative of y with respect to x? 10 gives me this equation, which is not a function. It looks like it would be an ellipse, wouldn't it? 2x squared plus y squared is equal to 16. Okay? If I want to find dy dx, let's take it term by term. What's the derivative of this? We know this. 4x to the first. How would you do this one? 2y, tack on dy dx by chain rule. Derivative of outer is this. Derivative of inner is that. Chain rule. Equals what? 0. What do I solve for? Dy dx. So I'll subtract 4x. 2y dy dx equals negative 4x. Last step. Divided by 2y. So dy dx, the derivative, is reducing to what? And a lot of times your answer will have an x and a y in it. Your derivative, your expression will have an x and a y. So that's fine. So think about this. If I said find the value of the derivative at a certain ordered pair on that curve, you could just plug the x and the y in there and you'll have that number. You'll have the slope of the tangent at that point, won't you? Even if this turned out to be an ellipse. If I had a certain point on that ellipse, if you plug that ordered pair in, this would be the slope of the tangent at that point. And you could write the equation of the tangent. Nice. Not hard, is it? Good. What do you call that?
Do I live?
Implicit differentiation.
Do I live?
Finding dy dx without having to solve for y. Right. Do you see 14 might be a good one. As they move along, you're not going to like them too much, but I say that a lot. But they just get sort of nastier, but it's the same thing over and over. Okay, let's try this one. If they say find dy dx by implicit, you know this. This is the trouble spot. This will have to be done by product rule. 5x times y. Well, we just said it. If you treat that like a product, I'll take the first times what? Derivative of second. Well, what's the derivative of y? 1. What do I tack on? Plus, the derivative of first is what? 5 times original second. Since I didn't take a derivative of y in that second part, I don't tack on dy dx. The only time I tacked on dy dx is when I took a derivative of a y variable. Okay? Equals, not equals, what's this one? 2y dy dx equals what? Equals 0. Derivative of 10 is 0. Okay. Do you notice this time I have 2 dy dx terms? Get everything else to the right. Let's subtract 2x from both sides. And let's subtract this 5y from both sides. Now what does it look like? 5x dy dx plus 2y dy dx is equal to negative 2x minus 5y. How will I get the dy dx alone? What can I do to it? Factor it out from dy dx times 5x plus 2y equals negative 2x minus 5y. Last step, divide by 5x plus 2y. And there's my answer. dy dx equals negative 2x minus 5y. And if you want to be nice, well, that's good. Put the x in front. It's already in front. 5x plus 2y. That's probably the best I could do. They might factor out a negative 1 from the numerator, but it wouldn't help them. And that's my answer. Do you see the tricky part? The tricky part was this had to be treated with product rule. It's 5x times y, product of two functions. And that's what usually bothers people about that problem. And when I found that derivative, it was this whole thing, wasn't it? That was the product rule right in the middle. Okay? Let's don't do 22, but do you all see what 22 looks like? How would you write 1 over x to the third power? X to the negative 3 plus what? Y to the negative 3 equals 5, then you just go for it. Okay? Let's see. Are you interested in trying 30, just for fun? Let's try it. 30. Is it not your idea of fun? X plus y squared to the 10 equals x squared plus 25. What will I have to use on the left-hand side when I take the derivative? Chain. Tell me, out. 10 times what? One plus 2y dy dx. Derivative of outer times derivative of inner. Okay. Equals what? How am I going to get that dy dx by itself? Yes. Divide by 10 x plus y squared to the 9th. And that leaves 1 plus 2y dy dx equals that. Then what? Minus 1, 2y dy dx equals 2x over 10 x plus y squared to the 9th minus 1. Last step. Do you think it would help if I divided each term here by 2y? Would that be better than putting the whole thing over 2y? Think about it. If you divide this fraction by 2y, it's like multiplying by 1 over 2y. So that would be like 2x over 2y times 10 x plus y squared to the 9th. And what would this be? 1 over 2y if I divide them both by 2y. Do you see why I left the 2y out here? I could cancel those 2's, couldn't I? And so I could probably make a nice last form. 10y x plus y squared to the 9th minus 1 over 2y. I hope the back of the book wouldn't make one fraction. That would be ugly. I like that. Okay. Chain rule. We have to use chain rule. Derivative of outer times derivative of that inner. When I took the derivative of y squared, it was 2y dy dx. That's, to me, that's as hard as they would need to get. But you understand where we're coming from with that? If you take a derivative of a y, you have to tack on dy dx. If you just take a derivative of an x term, it's just the same thing we've always done. So, okay. What about 32? Find the equation of the tangent line to the graph of the function by the equation at the indicated form. Well, 32 is not a function. I don't know why they use that wording in the instructions, but they should have said find the tangent line to the graph of the equation, or the relation. 32, the equation they give me, y squared minus x squared is equal to 16. They want the equation of the tangent line at the ordered pair 2 squared of 5. Okay. Well, to find the slope of the tangent, I need dy dx, the derivative, right? What's this going to be? Good. 2y dy dx minus what? Equals what? Like it? 2y dy dx equals 2x, right? If I add 2x to both sides? Last step. So tell me what dy dx is. X over y. I like that. Nice, simple result. Well, if the derivative is x over y, if I have this ordered pair, what's the slope of the tangent at that point? So the 2's would cancel, and what if you rationalize it? Would that be square root of 5 over 5? Would be your slope of the tangent. So now let's write the equation. Y minus y1 equals m times x minus x1. I don't know how far they want me to take this, but we'll try to put it in slope-intercept form. If I add 2 squared of 5 to both sides, y equals square root of 5 over 5x. Now let's see what that'll be. That would be, this would become 10 over 5. Yeah, 10 over 5 square root of 5. So 10 minus 2, would that be plus 8 square root of 5 over 5? Would you agree with that? This becomes 10 fifths, which is 2, with a common denominator of 5. 10 minus 2 is 8. Not a pretty answer, but that would be fine. That's the same thing we were doing, right? We would find the derivative, we would plug in, usually just the x value, but this time we had to plug in the x and the y. And we got our slope of the tangent, and we wrote the equation. That's okay, right? Okay. Now, we've got to apply this. The rest of the ones we want to do are some word problems that we call related rates problems. And I like these. These are real interesting. Look at this. When you see one of these related rates problems, this is what I'll have you do. This sounds easy, and I hope you'll find it's easy when you try it. Whoops. Read the problem and write an equation giving the relationship between the variables. Okay? Write down and label all values and rates of change given in the problem. Differentiate the equation implicitly with respect to time. Okay? Plug in the given values and find the required rate of change. Okay? So let's see. Let's see if we can apply that. Here's a good one. Number 40 on 226. 40 says this. And I'll bring this back up if you want, step by step. Oops. 40 says, a car leaves an intersection traveling west. Its position 4 seconds later is 20 feet from the intersection. At the same time, another car leaves the same intersection heading north, so that its position 4 seconds later is 28 feet from the intersection. If the speeds of the cars at that instant are 9 feet per second and 11, respectively, find the rate at which the distance between the two cars is changing. That sounds scary, doesn't it? But it's really not if we draw it. Okay? I'm going to draw the intersection. Here's the intersection, right? What did it say the first car is doing?
4 seconds.
Heading west, right? You want to say it's this direction? The other car is heading north, isn't it? Okay. After 4 seconds, it gives me the distances from the intersection, right? After 4 seconds, it's 20 feet. So after 4 seconds, this will be 20 feet. But it keeps moving, doesn't it? I'm going to call this A. After 4 seconds, this is 28, isn't it? I'm going to call this B. Right? And if I make a triangle here, I'll call that C. I bet you know now what the relationship between those three lengths are. So when this says, write an equation giving the relationship between the variables, what are you going to say? Yes. A squared plus B squared equals C squared. Right triangle. We know that. And you agree with my picture, don't you? West, north, right triangle. Okay. What did it say second? Write down and label all values and rates of change given in the problem. Well, they told me, what was A after 4 seconds? What was B after 4 seconds? And this was feet, right? Okay. Good. Could I find C? How? $20 squared plus 28 squared? Help me out with that. And the square root?
34.41.
Say that again.
34.41.
Love it. Give me this number again. You said it was 1100.
84.
That big? Okay. So I now know approximately what C is. Look what I have. I have A, I have B, and I have C. Okay? Before I write down anything else that's given, I'm going to do step 3, which said what? Differentiate the equation implicitly with respect to time. Well, let's take the derivative of the... Oh, whoa. Here we go. Okay. That was fun. What is the derivative of A squared? Tack on the derivative of A with respect to time. So differentiate with respect to time, right? Okay. Plus what? 2b, but the derivative of that inside b is what? Yes. And what is the derivative of the right hand side? Love it. That's exactly right. Does that make sense? Instead of, remember how we would tack on dy dx? Now we have to take the derivative of each of those variables with respect to time, and that's its rate of change at that instant. Okay? So now, what I need you to go back to step 2 for is I need you to tell me, didn't it say how quickly A was changing? What is dA dt from the reading of the problem?
9 feet
9 feet per second. The speeds of the cars at that instant are 9 feet per second and 11 feet per second. So dA dt is 9 feet per second. And what's dB dt? 11 feet per second. What am I looking for? I'm looking for the rate of change of c with respect to time. I'm looking for dC dt. That's my one unknown. Do you see I have everything else in that equation? Let's plug them in. So if I say 2, what is A? What is dA dt? What is B? What is dB dt? What is C on the other side? Times dC dt, sort of ran out of room. Okay? Well, it looks like 40 times 9 will be 360, right? What is 22 times 28? Well, yeah, 56 times 11 is what? 616 equals 68.82, is that right? dC dt. I bet you know what to do now. That's going to be, is that 68.82 dC dt? Divide. So dC dt is, drum roll, what? 11 feet per second. Do you see why this is called related rates? This, he was going 9 feet per second. He was going 11 feet per second. The question was, as they keep going, how quickly is C changing? How quickly is that distance between them increasing? Well, wouldn't you think that would be a little faster than 11? If they're both going, wouldn't that hypotenuse be growing at a faster rate? 14.8. Related rates. All right? I like it. That's what we were looking for. Well, what do you think? Did you see that a big component of this was drawing what was given? Because when you read the problem, didn't you think there's too much information here, right? But once it's drawn and it's a right triangle, that's easy. I knew everything. I knew everything to plug in there except my one unknown. Okay? Very good. Now, we don't have to do as much for 42. Let's look at 42. 42 says, the quantity X of these tires made available each week in the marketplace is related to the unit selling price by the equation P minus 1/2 X squared equals 48. Okay? X is measured in units of 1,000 and P is in dollars. How fast is the weekly supply of tires being introduced into the marketplace when X is 6, P is 66, and the price per tire is increasing at the rate of 3 per week? Well, first thing I'm going to do, look back at it again. Write an equation. They gave it to me. I don't have to do anything. They gave me P minus 1/2 X squared. Okay? Let's go ahead and do this. Before I write down all the values given, let's go ahead and take the derivative. Okay? So I'm going to skip down to step 3. And I'm going to say, what is the derivative with respect to time? The derivative of P is just what? 1 and tack on what? Yes. Minus what? 1. I agree with the dx dt, but if this is a square, what will I still have here? So I'll have 1x to the first dx dt, right? Equals what? 0. Okay? Now if I go back to step 2 and we write down everything that's given, let's write down what we're given. It says, how fast is the supply being introduced into the marketplace? Which will that be? The supply would be change in tires with respect to time. That's dx dt. That's what we're looking for. They gave me that x is 6. When x is 6, p is 66. And the price per tire is decreasing at $3 per week. What's that? Yes. And which is it? The dp/dt is -3 per week. Right? -$3 per week. That's change in price and all that's going on. Falling at $3 per week. All right. Well, let's see. If I'm looking for this rate, let's plug in everything else we need. So step 4, I'll say -3 minus 6 times dx dt equals 0. If I add 3, if I divide by -6, tell me what dx dt is. Yes. Now think about this. Didn't they say the supply was in thousands? What is half of 1,000? So that's -500 tires per week. Would that be how we would interpret that rate of change? The supply is decreasing at 500 tires per week, half of 1,000. Okay. What do you think of that?
Why does it then tell us what P is?
Oh, yeah, they told us P was 66, but when we took our derivative, we didn't even need P, did we? So that was a value we didn't even use in our calculation. But they told us what it was, in case we needed it. Sometimes in future problems, if there were more than 2 variables, you might have to put this P back in here to find like a Y if there was another variable, and that would help you. But this one we didn't even need. We just needed dp dt and x. What do you think? Did you do that? That was an easy derivative to find, wasn't it?
So the price stays the same, no matter what it's also.
Well, in this one, yeah, we didn't even need P. The price was changing at falling by $3 per week. So we used that rate of change, but we didn't use P itself. Okay? Can you draw 52? Let me give you a minute to try to draw 52. Read up. You can just use dots for the shoes. A is north and B is east. Thank you. Thank you. Thank you. Very good. What's the relationship? Good. Okay. Very good. Can you tell me the derivative of that? Does that look good? Okay. We have to read what we're given. It told me that A was going 15 miles an hour. So what is A after 1 hour? So if it's going 15 miles an hour after 1 hour, it's 15 miles from the intersection point, right? What about B? So actually, my A should be longer than my B, but you won't let me get away with that. All right. How fast is the distance between them changing at 1 p.m.? Well, what is dAdt? When the speed was what is dB? 12 miles per hour. We're asked to find this, and I'm going to have to find C again, right? So if we said A squared plus B squared equals C squared, I can find what C is. 225 plus 144. So you say that again?
19.21.
I like it. Okay. So if C is 19.21 miles, okay. Let's see. If I plug in now, 2 times 15 miles times 15 miles an hour plus 2 times 12 miles times 12 miles an hour equals 2 times 19.21 times dCdt. Is that 450 plus 288? 38.42 dCdt, is that right? 738 equals 38.42 dCdt. Did it come out to be what you thought it would be? It's actually what C was, just like all of this. 15, 15, 12, 12, 19.21, 19.21. And that would be in very good. Very good. Okay. Few more and we're set. I wanted to show you, the one I think had the error in it is 53, so I'm going to not let you, I'm not going to assign 53, but let's work it right now. Because I feel secure that they made a mistake in the answer section.
Now this number for all book with all the answers.
What's that?
So this number for all book.
Yeah, that sounds good. That would be a lot of work, though, wouldn't it? Then they would be calling us, you made a mistake on them.
You made
I'll release it in the new edition.
Yeah, that's what they say. That's exactly what they say. 53 says, in calm waters, the oil spilling from a ruptured hull of a tanker spreads in all directions. A Assuming the area polluted is circular, if it's a circle, what's the area of the circle? What's your equation? We know that. We know A plus pi r squared, don't we? There's my equation. Now that they start asking the questions and giving values, go ahead and take the derivative for me with respect to time. What's the derivative of A? So just in terms of the variables that are here, you want to just call that d a dt? 1 d a dt? d a dt? And remember, pi is a constant, like 3.14. It's a number. It's a coefficient. So what would this be? 2 pi r to the first times what? Yes. Good. There's my equation. Okay? Now let's see what they tell me. They tell me in this problem that determine how fast the radius is changing. So I guess this is our unknown. That's what we're looking for, right? dr dt. When the area is 1,600 pi square feet and increasing at the rate of 80 pi square feet per second. What is the 80 pi square feet? Which of those? Yeah. Is this 80 pi? d a dt, how quickly the area is increasing of that circle? You see what's happening? That oil is going out in all directions in a circle, right? So it's increasing at that rate, 80 pi square feet per second. Now, what they haven't told me is what R is. And I'm looking for dr dt. But I can find R because they gave me A, didn't they? What did they say A was? What was this plain old area? 1,600 pi square feet. Okay. Was the area of the circle? Square feet, is that right? That's square. Feet square. So then we want to say that's equal to pi squared. Can you tell me what R is? If I divide by pi, they'll cancel. So 1,600 equals R squared. So what is R? 4. Is it? So yeah, can we divide by the pi then? Pi's cancel. And the square root of 1,600 is 40, right? Is that right? Yeah. Yes, right. So if R is 40, I can plug that right in. And now I can, would you agree here that pi's will also cancel? So if 80 equals 80 dr dt, what is dr dt? 1 foot per, what was the unit of time? Second. So the radius of the circle is increasing at a foot per second when the area is 1,600 pi square feet. That makes sense, doesn't it? You can see that circle increasing at a foot per minute, a foot per second. That's going pretty fast. That is filling up the water, isn't it? That's bad. Disaster. That's a good problem, isn't it? You know what the back of the book said was 3.14, so they thought it was pi, so they must not have canceled their pi's correct. But I swear that that's correct. In my mind, that is it. I think they made a mistake. Because just think, if the radius of that circle is increasing at 3.14 feet per second, that's going fast. That seems more likely to me. It's still a great problem.
Maybe they were hungry.
What's that?
Maybe they were hungry.
They were hungry, maybe. Are you hungry?
When you think about pie, I mean,
Oh, pie. Yes, they kept that pie. Can you sketch out 56? We're down to our last two, I think. 56. Man observes a helicopter taking off. So here's the man, and here's the helicopter. What's it going to do? It lifts off vertically, so it's going to go straight up again. Okay. What's different about this problem, though? Is this distance ever going to change? He's 50 feet from the launch. So it's just 50 constant, isn't it? It doesn't change. It's not a variable. But these two are. This is increasing, and this distance between it. As that increases, that's going to get longer and longer, isn't it? So do you want to call this maybe A and C? Okay. Let's go ahead and tell me what my equation is for this one. A squared plus what? 50 squared equals, because 50 stays the same, doesn't it? They're going up, but that stays the same. All right? So, go ahead and take the derivative with respect to time. 2a times what? 2a dt. What's the derivative of 50 squared? 0. How about this one? There's my relationship between the rates of change. Okay? Now let's see what it said. It said the helicopter lifts off vertically and is rising at 44 feet per second. What is 44 feet per second? dA dt is 44 feet per second. When it is at an altitude of 120 feet, what's 120? A is 120. How fast is the distance between the helicopter and the man changing? So what am I looking for? I'm looking for dCdt. What I don't have is C, but I can find it from my original, right? So I'll say 120 squared plus 50 squared equals C squared, and you'll help me out. C is 130? Okay. So if you do that, pick the square root, you get 130. I like it. So let's plug in that. 2 times 120 times what? 44 equals 2 times what? 30. Let's see, give me the left-hand side. What's that? 240 times 44?
Be a total of 10, 560.
What, say that again?
10, 560.
So the left-hand side is 10, 560, do you agree? And that's 260 dCdt. And if I divide by 260, dCdt is 40.6, sounds good. And that would be in feet per second. That to me sounds like pretty good. If it's going up at 44 feet per second, this distance from the man is going to be increasing faster than that, right? So, well, actually, no, it's slower, isn't it? It's slower. So, I guess, yeah, if it's going up 44 feet per second, the way he's seeing it, it's going to be just a little bit slower than that. So, that was pretty good. It would be faster if he was running the other direction, I guess, right? If the 50 was increasing also, then it was good. But since the 50 was constant. But he wasn't running from the helicopter, so that's good. Last one. This one's good. 64. They've even sketched it for you. Wasn't that nice? 64 says there is a 20-foot ladder against a wall. It begins to slide. How fast is the top of the ladder sliding down the wall? The instant of time when the bottom is 12 feet from the wall and sliding away from the wall at the rate of 5 feet per second. Okay? So, if I just make a quick sketch of it, the ladder stays 20, doesn't it? It's going to start falling down, but it's going to stay 20. They're calling this Y and this X. Okay. What is my relationship? And they even tell me that. X squared plus Y squared is 20 squared. Okay. Because 20 is my hypotenuse. All right. Which variable is going to be, go ahead and take the derivative. Let's take the derivative. 2x dx. Like 2x dx dt plus 2y dy dt equals 0. All right. What is 12? The bottom of the ladder is 12 feet from the wall. That's x, isn't it? What is 5 feet per second? That's how quickly this x is changing, right? They even told me that. They were so nice on me. Okay. How do I find y?
What do you mean?
From my original equation, 12 squared plus y squared equals 20 squared. 44 plus y squared equals 400. Y equals 16. Very good. Okay. If I subtract 144 and take the square root, 16 feet. Let's see what we get then. 2 times what? Um, 120, is that right? 32 dy dt. 32 dy dt. 20 dy dt equals
Yeah, the 3.75.
Tell me if this makes sense. Y is actually decreasing as that falls down, right? So it's decreasing at 3.75 feet per second. I would expect that to be negative if this length is getting smaller, right? Y is decreasing that quickly. That's why it's negative. These aren't that bad, are they? Once you think about it, I sort of like them. I like them. Okay. The ones I've picked out for you to try are from page 225 and beyond, 1 through 33, every other odd. I thought if you went just every other odd, if you came across one that was real ugly, of those first few, that it wouldn't be too bad. Then try 41, 43. We already did 53, so I'll skip to 55 and 65. And those are the only ones I would like you to try for practice. Let's see if you get them right. Make a note that Monday I want to have a quiz over what was the section with the marginal cost revenue and profit. So 3.3, 3.4, and the first half of 3.6. 3.3, 3.4, and I'm going to say 3.6, but only the implicit, not the related rates yet. I didn't put those on this quiz in case you had trouble, but I don't think you will. Yeah, these word problems will be on your quiz that's before the next test, I think. So just be ready for this, for chain rule, marginal cost, revenue, profit, and implicit. And we will start chapter 4. I'm going to skip 3.7 for now. We might pick it up at the end if we have time, but I'm going to go into 4.1 and 4.4, and then we're ready for our next test. Okay? So I've got good notes for 4.1 and 4.4 on D2L if you want to print them out. Might make things easier next week, but hopefully it's going to be smooth sailing. But let me know how those go, and we will pick back up Monday. See you later.